Hi, this project is related to centralized multi-board path planning using the particle swarm optimization and Bézier curves in MATLAB. Basically, in this complete project, we are discussing the PSO technique for the multi-board path planning, in which we just used as a report to avoid the obstacle avoidance, collision prevention, and trajectory smoothing. So the PSO algorithm is basically minimize the cost of function. Just a second. Basically, I have just run that file in before. Let me just show you after that. Just a second. Okay. So uh, PSO algorithm basically minimize the cost function and balance the path length smoothness with the clearance from the obstacles. So in the PSO algorithm, we have just used our board to feasible for the its efficiency, for its simulation purpose, for its avoidance of obstacles, and it's the path planning problems it needs to demonstrate through effective in finding feasible and efficient paths. Okay, so I have just written the complete abstract with the explanation of how PSO is work with the multi-report path planning problems. Okay, so here is the keywords with the introduction. In the introduction, I have just written all the mechanism of the multi-report path planning in details with the obstacles and collisions avoidance. Okay, so this is basically the multi-report path planning general diagram. These are the path planning according to like how it avoid from the obstacles. Okay, so these are the lines for the path of the board to avoid from the obstacles. Okay, so okay, yes, this table represents the parameters used in the PSO path planning. And yes, PSO-based Bézier curves basically used can be used to smooth the paths generated by PSO. Okay, through feasible and efficient report motion. So this is basically the planning optimization, like the robots optimized trajectories during the multi-robot optimization trajectories. Okay, so here is basically this article organized in different sections. One section is provided as the related work in the multi-report path planning, and the section 3 basically proposed the PSO based approach, and section 4 represents the simulation and results according to our report which we have developed in the MATLAB. So here's the background with the motivation and the problem statement with the challenges. Basically, problem statement is same. We need to use obstacle avoidance. We need to consider the collisions with each other. We need to consider to avoid any the board should be worked in any environment, uh, like for example when the wind is coming the boat should resist and survive in that environment as well. So these are the problem statements and we need to cover these challenges during the purpose of robot. Okay, so here's a propose and approach is basically we are using a PSO, and the second one is Bézier algorithm. Basically we are using. So here is basically the related work contest, which is basically previously they have designed grid-based discretization with the potential fields and widely used in path planning and robotics basically, but in right now improved PSO algorithm used for the multi-robot path planning with the technique used in different aerospace, in robotics, in computer vision, and different simplicity and feasibility ability to handle complex cost functions as well. Okay, so here is the PSO parameters like the particles 60, max iteration 300, and everything is considered in this table. Bezier curve, basically Bezier curve is the smoothing and trajectory generation. Bezier curve is basically used to ensure that during the robot is that it should be feasible and efficient robot motions. Okay, and Bezier curve also uh, parametric widely used in the computer graphics with the robotics, and in our case Bezier curve basically provide us smoothness with the optimized paths and generating the smooth and feasible trajectories for the robot. Okay, problem statement is open. I think just a second. Okay. Yes, basically this is a problem statement. In the previous section 1.2, we have just developed the problem statement with the challenges, but here is a problem statement in which I have just described that how the traditional and the um, robot is working and how our robot, what is our goal. Basically this problem statement we called it the objective of the our approach. Okay, so the mathematical approach is written here, in which we have just used path length with the smoothness with safety. Okay, and path length with the smoothness and the safety also covers with the times of trajectories and minimum cost function with the uh, cost function called J. Meta heuristic optimization method basically used for the PSO algorithm, which is basically used in terms of in terms of gradient information, in terms of Bezier curves for their inherent smoothness, each of constraint handling. So here is the methodology with the objective weight tables, with the safety parameters table, with the design and oh, smoothness with the clearance and the obstacles. And here is the MATLAB simulation with its analysis, which is basically provide us the complete problem setup with PSO initialization, PSO main loop, cost function evaluation, helper functions, and centralized approach with the obstacle avoidance with the collision prevention, as well as the here is the multi-report path output results according to the centralized PSO. Okay, so yes, these are the report, which is basically three simple animation for the report, like how the PSO algorithm works. This is a final smooth multi-report path. Okay, these are the trajectories with the raw waypoints according to the comparison of trajectories through three report basically. Okay, these are the trajectory. Yellow line shows the trajectory part, and see the raw or 3 means uh, circle lines are raw, represented the raw points, and the smooth path displaying the solid line. Okay, so here is the PSO convergence curve generated from the MATLAB, and here is a particle best fitness per article as well, and the inter-abort distance over the time as well. So the discussion with the results and the conclusion added with the references as well. Okay, let me just show you the complete. Okay, just a second. See, clear out, close out. Okay, clear out, CLC. See, this is the MATLAB code which I have used in our case to represent the MATLAB functionality of that robot. Let me just run. Sometimes the MATLAB is just taking too much time, but let me check it. If it is not working, let me just provide another video, or I will add another MATLAB to optimize and run this MATLAB file. Let it just MATLAB. Basically, I'm using two MATLABs. One is MATLAB 2025B and one is MATLAB 2021. Sometimes this MATLAB having issues with the running of graphics because this is a new version of MATLAB. But sometimes it works. But in the MATLAB 2021, it works fine and it shows the results accurately. Okay. Yes, I think there is a problem in the MATLAB multi-report graphics problem. Let me just wait for the another MATLAB. So here is our topic and multi-report PSO algorithm. So here is the article 1 MATLAB running video. Let me just run this code. So the iterations are moving in terms of 300 total iteration, and every 20 of iteration works with the time span. So when 300 completed, so it will show us the output results. See, 220 is completed. 280 completed, and next is 300, and then it will show us the output results. Yes, so finished with the objective is 1.4 e power 4, 1.043443. See, all the comments are added in the code to explain everything. See, these are the figure 1 for the multi-board path planning using centralized PSO, and this is the animation of robot accordingly. Okay, so here is the inter-robot distance over time with the particle best fitness as well as the PSO convergence curve, raw points with the smooth functions, and the final smooth is multi-robot paths. Okay, so this video is completed. If you need to ask anything, you just ask me. I will answer your questions. Thank you.